Okay, good morning, everybody. Hope you guys are doing well. Today we're going to talk about the section 3 on the algebra review packet. And this section deals with radical expressions and complex numbers. So I'm going to go over the first couple of rules here, which are, if you look under radical expressions, it says multiplying radical expressions. If nth root of a and the nth root of b are real numbers, then the nth root of a times the nth root of b equals the nth root of a times b. Basically, what it's telling you is you can multiply everything underneath the root as long as the root base is the same. So, as an example, if you had the square root of 2 times the square root of 3, you can see that these are both square roots. No, if one was a square root and one was a cube root, you would not be able to do this. But because they are both square roots, you can do this. So the square root of 2 times the square root of 3, we can combine and just turn that into the square root of 6. And that would be your final answer for that one. The dividing radical expressions, if the nth root of a and the nth root of b are real numbers and b is not 0, b cannot be 0 if it's on the bottom of a fraction, then the nth root of a divided by the nth root of b can equal the nth root, one big root, over the entire fraction. So an example of this would be if I had the square root of 8 over the square root of 10, the 8 and the 10, you can see, can be reduced, but before we reduce them, we want to rewrite them as one big square root like this, 8 over 10. Then we'll proceed to reduce the 8 tenths. So the 8 tenths would reduce to 4 fifths. Now we can break that root back up and make it the square root of 4 over the square root of 5. And hopefully you recognize the square root of 4 is a perfect square, or 4 is a perfect square, so that turns into 2 root 5. Now you might think we're done there. Unfortunately, we are not. You cannot leave a rational expression with a radical in the denominator. So we need to rationalize that radical. And the way that we do that is you multiply by itself. In order to get rid of a square root, you square it. That is the opposite operation. So we actually need to multiply the top and the bottom by the square root of 5. And so when we do that, you end up with this 2 root 5 on the top, and on the bottom you have square root of 5 times the square root of 5, which is the square root of 25, but that reduces to just 5. That's your final answer. And in case you're thinking, well, maybe these 5's can cancel, they cannot cancel. One of them is under the radical, one is not, so they will not cancel out. So your final answer for that one would be 2 root 5 divided by 5. Okay, now for example, says simplify each of the following rational expressions. Be sure to rationalize the denominator if necessary. And then it takes you down through step by step. This is all actually one problem. So I'm gonna, I can do it to the right of this, I think. I'll have enough space. So I'm gonna kind of explain and write each one of these steps, but this is the one that we're starting with. So we have the square root of x to the third divided by the square root of 5xy. So we're going to start, because it's individual square roots and we want to try to simplify, we're going to rewrite this as one big square root, and then we're going to have x to the third on the top, and we're going to have 5xy on the bottom. And now we can look and see, okay, we have an x to the third on top, we have an x to the first on the bottom. And so since there's more than one variable, we're going to work to get those combined. So if you remember from the previous day, the rule is if you have a base and a power on top and a base and a power on the bottom, the bases are the matching, you subtract their powers. So 3 minus 1 becomes 2, and we end up with x squared on top and then 5y on the bottom. All right, so you might say, well, good, we're done. Well, again, as with the last example that I just showed you, when you have a giant square root, that giant square root really translates into there being a square root in the denominator. And if there's a square root in the denominator, you cannot leave that as your final answer. You have to rationalize the expression, so there is no longer a square root in the denominator. So in this case, in all cases, in order to get rid of a square root, you need to square it. And squaring it means multiplying it by itself. So we're going to multiply both top and bottom of the fractions, so we keep the expression the same. We're multiplying it by the square root of 5y. Now on the top, we had a rule that says if the power of the root or the power of the power, we can combine the bases or multiply them. In this case, we can multiply the x squared and the 5y together, and it is going to become 5x squared y. If you notice there, we always list the number first, and then you alphabetize the variables. So it's 5 and then x and then y. Now on the bottom, we're squaring 5y. Square root of 5y times the square root of 5y is the square root of 25y squared. And when you square root that, it just turns into 5y. And that is going to be your final answer. And no, the 5's won't cancel, or the y's, because the 5 and the y on the top are underneath the root. The 5y on the bottom are not. So that is going to be your final answer. And I actually lied. I apologize. There is still an x squared there. One more thing I actually almost forgot is if there are any powers equal to or larger than the root power, it needs to come out. So in other words, this is a square root. So under the root, you should not have any squareds, third power, fourth power, fifth power. If you do, then they need to come out. And I'll show you how I do this. You always want to have powers of 2. Square roots cancel out squares. So you're going to underline this base, and that wasn't a good color to choose. Let me try this. Let's try red. I'm going to underline the x, and I'm going to cancel out the squared. Again, the square root is canceling the square. Why did I underline the x? I underlined the x because the x now, the base of that is going to come out outside the root, and we're going to leave it as 5y on the top and then 5y on the bottom. Now, this is the final answer this time. And again, the 5y on the top is under the root, so it will not simplify with the 5y on the bottom. You leave those alone. There's a little mark right there, and I apologize. I still didn't really do it, but um, I only want to get rid of that little teeny mark right there. There we go. So you don't think that's a negative sign. So there's your final answer. All right, guys, hopefully that made sense. Make sure that you're getting your work done on time, and I will talk to you soon. Bye.